This is my Cisco packet tracer implementation of my designs from coursework 1 of Fundamentals of Computer Networks, SOUD 1505. As you can see, we have our different departments here. We've got resources, we've got management, we've got sales, we've got accounting, and we've got marketing down here. Each switch has been encrypted. It has an encrypted password, so this is our default password, so we have basic user access. To enable the config, we have to type in enable, and we have to type in our secret password as such, and to get access to our configuration terminal. This is the same for our ISP router, same procedure. Type in our user access password, and then type in enable to access the config terminal, which you have to require your secret password to access. As such, I have created, I've enabled DHCP on this router. So if we add a separate terminal to our network using a crossover cable, and wait for that to boot up. In the meantime, I will explain the wireless access point. We have a smart device here which already has a DHCP configuration within our subnetting network requirements. You can then add another device to connect to this. It should pick it up straight away, and then we have to request a IP from the server, which we already have, just like that. Now this is the same with wired connections. We can go into our IP config, click DHCP, request an IP address. The DHCP has been given, and we have our new IP address, so we can communicate to other devices on the network, such as if we head over to our command prompt and we ping our server 0, which is 192.168.1.1, we should receive a reply as such. I have created VLANs for the entire network. So if we head over to our main switch, go into our VLAN database, we have our default, which is our server management, server resources VLAN. We have our management, we have our sales, marketing, and accounting. Now with this VLAN, you can only access devices within that VLAN. So for example, this computer over here has the IP address of 192.168.3.3. We head over to this PC and we try to ping that address. 3.3, we should receive no reply back from it. However, if we can receive a reply from any machine in our virtual LAN. So if we ping 192.168.2.2, which is this PC over here, we should receive a reply as such. And these are all separate. However, I have linked these two together. These two both have access to, well, this VLAN has access to this VLAN. So I might not be able to communicate with these are other VLANs. However, if I try to communicate to our server one more time from this machine here, so if you do ping 192.168.2.1.2, we should receive a reply as such. There are multiple commands we can use to diagnose issues on the network. For example, we can look at our running command. We can look at show running config, sorry. So we can see what configuration our router has. If we go to show running config, this config can be used to show off the different configurations we have, and once we're happy with our configurations, and we want our router to remember our configurations on startup, so anytime the router starts up, it will apply the configurations. We can insert a command that copies over the running config to the startup config by pressing enter and then pressing enter again. A configuration has been built, and now if we take a look at our startup config, we should now see the SOUD configuration. Another command we can use is show interfaces to show our different packets being sent and other different types of errors that could occur during packet transfer. Here are some as an example for all of our different interfaces. For example, this is our 9th Ethernet port, and we have our first Ethernet port up here. We have our second Ethernet port, then our first Ethernet port. We can have multiple issues within our network. For example, duplicate IPs. This might occur when an IP address is set by the DHCP of our edge router. A pretty simple fix is to simply run another DHCP request and receive a different IP address. Make sure that works. A way to combat that is set our edge router to delete any IP addresses it's created within the last 24 hours. So every day a new IP address is given to every device, therefore removing the duplicate IPs problem. Different subnet masks. This won't happen with the DHCP as it has been set to give IP addresses within our set subnet mask range. However, when setting up a PC manually and changing its address statically, it's possible that we could use the wrong subnet mask, which isn't this, obviously. Another common issue is incorrect cabling. For example, we have used crossover cables for all of our devices at the moment, as that's how PCs connect to each other. We would only use a straight through cable if we were connecting two clients together. However, since it's all client server, this straight through cables aren't really needed. Another potential issue is our network card of our devices just isn't functioning properly or is turned off. A simple way to fix that is to go into our device manager and see if there are any issues, any errors, or if the network card is disabled. That should be it for my network design. I've explained VLANs, our passwords, our wireless networking, and proven VLANs working together. I hope you enjoyed.